Okay, hi, my name is Esther. So I'm going to explain the question for question 37 for Red Bull. And I started by setting up the objective and decision variables, where the objective was to maximize the profit of the Red Bull, and to determine the decision was to determine the amount of each ingredient that will be used in Apoting and Raymond Tang drinks for Red Bull. And going down, I extracted the variables where I named TL the amount of taurine in lemon tea drinks, and FL the amount of flavoring, CL the amount of carbonated water, and T the amount of taurine apple drink, and FF the amount of flavoring apple, and CA the amount of carbonated water in apple. Going down, the objective function, the unit profit of apple drink was $6, and the unit profit for the apple lemon thing was 5.5. So which means I extracted the profit and said if a can of lemon tang drink generates $3, and they said that one can is 500 milliliter, which means if you put it in liter, it will be 0.05 liters, and 0.5 liters will generate $3. So which means 1 liter of lemon tang will generate, you will take $3 and times 1 liter, and you divide by 0.5 as you get $6, the unit profit for lemon tang drink. And for the apple thing drink, they gave the profit of $2.75. So which means one can of drink will cost 500 milliliters, 0.05 liters, as they said in the prompt, and 0.5 liter generates 2.575, and I did the same process, and I got $5.5 for apple thing drink. And going down to and the maximum profit will be $6, and multiply the amount of which is going to be produced for apple thing and lemon thing, and the maximum profit will be 6 TR plus 6 FL plus 6 CL plus 5.5 TA plus 5.5 A plus 5.5 CA. Going down to the constraint, I generated the constraint told in the prompt that the amount of each drink, their variable amount. For lemon tang, they say that it is having 25%, no more than 25% of taurine, which means it is going to be 0.25 of lemon tang for each lemon tang. And for the flavoring, they said is 10%, which is going to be 0.1% for the each lemon tang. And they said carbonated water is 35%, which is going to be 0.35. And generating from that, if you take 0.25 and you 0.25, you multiply each and everything in the bracket, you come up with this equation, which is 0.75 TR minus 0.25 FM minus 0.25 CL. And I did everything for the whole process, and the questions which came out were these ones. And coming down to the amount taurine available, they said for the taurine it will be no more, it will be the amount of liters is going to be 2,500 liters, no more than that. So that is what is available for taurine. And amount flavoring, it is no more than 2,600 liters, and the carbonated, it is no more than 4,000 liters. And they say that in amount of taurine available for upotting is to be 600 liters, which means for taurine is greater than or equal to 600. And coming to the then, okay, so for the sensitivity analysis, they said that how will an increase of the minimum amount of taurine used in upotting from 600 liters to 750 liters to affect the optimal solution. And we can see that the allowable increase is 1050. So which means that if we get 650 liters minus 600 liters, we get 150 liters. And the upper increase, the allowable increase limit is to exceed 1050, then one will need to rerun to solver. So, and since an increase will affect the optimal solution negatively, and the shadow price, we have a negative sign, which is negative 4.5. And that will be at least sum of taurine utilized in upotting. The optimal solution will diminish by 4.5. And to each unit we increase, we take negative 4.5, which is the shadow cost, and multiply by 150, we got from the increase, and we get a negative 675. And the optimal solution we end up being the one we have, which is 50,100, and you minus the proposed change, which is negative 675, and we end up getting for $49,425. So on the optimal for the Red Bull, the optimal solution of the ingredient of upotting and lemon tang Red Bull with which is 600 taurine, 180, and everything we got from 800, 340, 600, and 1,800, and the carbonate water in apple tank, which is 600. And to create the upotting drink, to get the extreme profit of 50,100 to $1,000, given the foreign constraint, during the 400 liters of taurine, 800, and everything for decision variables, the solution assumed that Red Bull will deliver Olympic carbonated water for required ingredient of 3,400, and which is more than what is expected to be produced. So therefore, the apple tank is expected to, so which means that for the apple lemon subusting lemon tank handout, excess is binding, and in the content enhancing carbonated water as visible finite to maximize the profit. So we can see that here the apple for the for the thing of the lemon for the thing of lemon tank, for the taurine available is 2,000, which means there is an excess, a slack of 500, and that we have to reduce for the apple tank, and that I will recommend that they should, the company has to utilize its capacity and therefore I would recommend less ingredient in taurine in order to induce more profit workout for Red Bull, which will be more beneficial. Ready to see that there's a change of 150 liters and an increase of capacity of 2,600 and carbonated water for capacity to 4,000 liters. This means that over 500 liters are part of enhancing carbonated water from taurine capacity, and this appear that the company doesn't get to upgrade or increase the space they need to utilize this store enhancing the carbonated water as a result. And the optimal benefit we still will accomplish, which is 50,100 will accomplish, and then the adjustment was made. So the assumed optimized benefit is 51,100, and the event of taurine capacity is 2,500 liters is essentially more noteworthy than they are anticipated. Thank you so much.